Hello everyone, welcome back to This is Stoichiometry Part 2. So now that we kind of know a little bit about what stoichiometry is, we're going to look at how we can use it to calculate reactants or products. So we're given this balanced equation. We have nitrogen and hydrogen making ammonia. The coefficients tell us how many moles we have of each reactant and product. And we can use that to write mole ratios for this reaction. So for example, for every 1 mole of nitrogen, right, we need 3 moles of hydrogen. We could also say for every 1 mole of nitrogen, we can make 2 moles of ammonia. And then our last one, we could write a ratio between for every 3 moles of hydrogen, we can make 2 moles of ammonia. Now, it doesn't matter, I did 3 moles of hydrogen over 2 moles of ammonia. You could flip that and put 2 moles of ammonia on the top and 3 moles of hydrogen on the bottom. And we're going to see, once we get into these problems, sometimes these are flipped, right? But it's just showing a ratio between all of your different reactants and products. So, if we are converting between moles to moles, so this is going from one reactant to another or a reactant to a product, we use our mole ratio. So that's how we can switch from one reactant to another or a reactant to a product. Okay? Now, we're going to use, in stoichiometry, it's T-charts just like we've been using. So again, we always start with our given. So we want to see in this first example, if we have this many moles of hydrogen, how much nitrogen do we need to react with all of this hydrogen? So I'm going to start with my given, 14.8 moles of hydrogen. Okay, and I know I'm trying to get rid of moles of hydrogen, so I put that on the bottom. And I look and see I'm trying to get to moles of nitrogen, so I'm going to put that on the top, all right? And then we look for our ratio. So our ratio said for every 1 mole of nitrogen, we need 3 moles of hydrogen, okay? So we got rid of moles of hydrogen, we have moles of nitrogen, which is what we need, so we're going to solve, right? 14.8 divided by 3. And I got 4.93. We started with 3 sig figs, so I keep 3 sig figs, and then my units. Moles, and this is of nitrogen. So that's my final answer. Okay? So what I want you guys to do now is try this next one right here. So pause this for a little bit. Try this one. And then you're also going to try, I'm going to get rid of this entire you try section, right? This you try 1 through 4. So again, you're going to pause the video, try this one, and you try 1 through 4. I do have a picture of this note sheet. I don't have all the work, so you don't copy all the you try, but I do have all the answers that you can check those. Okay? All right, so now you have finished all these. You've checked those. You're good with that. Now we're going to look at moles to mass. So we've talked before that moles isn't necessarily helpful because we don't have a way in the lab to measure moles. So we need our grams. Okay, so this is going to be 2 steps. So to go from moles to moles, we just did that. We still need our mole ratios. And to go from moles to grams or grams to moles, you know that we need molar mass. Okay, so again, I put here, these will be 2 steps. So we need our mole ratios and we need our molar mass. All right, so this first example I took, this is the same reaction you did on the front. So you already have all your mole ratios written out for that. So I'm not going to rewrite those. Okay, next I'm going to go through and figure out my molar masses of all of these. Now remember, molar mass is always 1 mole. So I'm not factoring in this 4 when I look up the molar mass of aluminum. So that's 26.98 grams per mole. O2, I do factor in this 2, right? Not the 3, but the 2. So oxygen is 16. I'm going to do 2 times that to get 32 grams per mole. And Al2O3, I'm going to add up 2 aluminums plus 3 oxygens, and I wound up with 101.96 grams per mole, okay? Now, we have all this information that we need to solve the next few problems. So let's see what we have. How many grams of aluminum are needed to react with 1.5 moles of oxygen? So I always start with my given, 1.5 moles of oxygen. Okay, I'm trying to get rid of moles of oxygen, so I'm going to put that down here. we want to get to grams of aluminum. We cannot go straight from moles of oxygen to grams of aluminum. Somehow we have to go from oxygen to aluminum first. So that's where our ratio comes in. So I'm going to do to moles of aluminum. From your ratios or from your balanced equation, for every 4 moles of aluminum, we need 3 moles of oxygen. Okay? So we have moles of aluminum, but we need to get to grams. So I'm going to do another step, put my moles of aluminum on the bottom. I can change that to grams of aluminum, right, using my molar mass. We know for molar mass it's always 1 mole, and my molar mass was 26.98 grams. So when I solved this, I got 54 point something grams, but we were only given 2 sig figs, right? So I'm going to do 54 grams of aluminum. That's my final answer. Okay? So this one is similar to that. I want you guys to try this one on your own. Again, you can look at the picture to check that. But I do want to do this one together because this is the reverse. Reverse. We're starting with grams and we're going to moles. So again, always start with our given. So 15 grams Al2O3. Okay, I'm going to put grams Al2O3 on the bottom. Grams we can change to moles. Al2O3. Remember, our molar mass is always for 1 mole, and my molar mass up here was 101.96. Okay, got rid of grams. Now we have moles of Al2O3, and we're trying to get to moles of oxygen. So I'm going to use my ratio that you either filled in the front or wrote here, or my coefficient. So 3 moles of oxygen for every 2 moles of Al2O3. Now I'm left with moles of oxygen, so I'm ready to solve. For this one, I got 0.221. This had 3 sig figs, so I'm going to keep 3 sig figs, and I need my units. Moles of, we ended up with O2. Okay? So now you guys are going to work on the U-try, finish the rest of the sheet. So again, I posted answers to the U-try on that picture. All the examples, the work is on It's Learning. Help each other, do the best that you can, and we will take a look at this and go over it and answer any questions you have next time. I would like to give a thank you shout out to Chase Ella for the great camera work.